So today we are going to talk about the measuring instruments. Okay, so we studied about what dimensions, then we studied about the errors in measurements. Now let's talk about the measuring instruments. So particularly we'll talk about the vernier caliper. So what does this vernier caliper do? So now let's say you take a meter scale. Okay, then how much is the least count on meter scale? This is 1 centimeter, and the minimum distance which it can measure, it is 1/10 of a centimeter. That's 1 mm. Okay, 1 millimeter. Now sometimes we want more precision, and for that this kind of scale is used. So this is known as vernier scale. It looks like this. Okay, so let's say I want to measure the width of this pen. If I want to measure it with greater precision, what will I do? I will use a device like this, a vernier caliper. Okay. If I want even better precision, I will use screw gauge. All right. So it is kept over here. Okay. So this cross-sectional area, it is fitted over here, and then the reading is taken. So now, so let's see what's the working of this vernier caliper. Okay. So here you can see that this is the main scale of vernier caliper, and this is the vernier scale. Okay, so now on this vernier scale you can see these are readings. Okay, these are markings. So the 10 marks on vernier scale, they are matching with 9 marks on the main scale. Now if I zoom it further, okay, if I zoom it even more, I can't go beyond this, but you can see this. You have this marking, okay, and this marking. So can you measure distance between these two markings? So we can measure this much minimum distance. Okay, so this is known as the least count, the minimum distance that can be measured with any device. It is known as the least count of that instrument. Okay, so let's see how is this least count calculated. So least count of vernier caliper, it is 1 main scale division minus 1 vernier scale division. Okay, so it is 1 main scale division, which is this much, minus 1 vernier scale division, which is this much. So how much is the least count? It's this much. Got it? 1 main scale division is this much, and 1 vernier scale division is this much. Vernier scale division is this much. So this minus this will give you this much distance, and that is the least count. That's the minimum distance which can be measured by vernier scale. Okay. So now, how do we find it? So let's say n division of vernier scale, they match, okay, they align with n minus 1 division of main scale. Okay. So here that n and n minus 1 is how much? So the 10 marks on this vernier scale, they match with 9 marks on the main scale. Okay, 10 marks match with 9 marks. So how do we find one division on vernier scale? So we take this n on the other side. Okay, we take n on the other side. So we'll get what? 1 division on vernier scale is equal to n minus 1 divided by n divisions of main scale. Okay, so how much is that over here? How much is n and n minus 1?
N is equal to 10, n minus 1 is equal to 9.
N is equal to 10, n minus 1 is 9. Okay, so it is 9 by 10 division of main scale. Okay, so let's find it out for this scale. Okay, so now least count is 1 main scale division minus 1 vernier scale division. And now if I substitute this over here, so this is 1 vernier scale division, what do you get? So it is, see, 1 main scale division and 1 vernier scale division is n minus 1 divided by n division of main scale. So I can substitute here as n minus 1 divided by n of main scale division. Okay, so that's what I'm doing. I'm substituting that over here. It is n minus 1 divided by n main scale division. Okay, and then 1 minus this n minus 1 divided by n will give me 1 by n. Okay, because 1 can be written as what? N divided by n. Okay, so it is n divided by n minus n minus 1 divided by n. So you can take n common, so it is n minus 1, which is what? 1. Okay, so it is 1 upon n main scale division. Got it? This is the least count.
Yes, sir.
Yes, sir.
Okay, so now how much is the least count of this scale, this vernier scale over here? The least count is 1 divided by n of main scale division. So how much is the main scale division? This much is 1 millimeter for this particular scale. Okay, so this much distance is 1 millimeter. Okay, and now how much is n? It is 10, right? 10 matches with what? 9. Okay, so n is equal to 10, and our least count of this device is 1 division of main scale divided by number of divisions on the vernier scale. So it is 1 mm divided by 10. How much is that? 0.1
0.1 mm.
mm. Okay, so for this particular scale, I can say it is equal to least count of this scale. So let me write over here. So for this particular scale, the least count is equal to what? 1 mm divided by 10, and that is 0.1 mm. Okay, so we found the least count. All right, so this is the formula to find out least count. So now let's say the division on your main scale, it is x. For this scale it was 1 mm. Okay, so the least distance that can be measured by your main scale, it is suppose x, it can be 0.5 mm too. Okay, so x will be equal to what? In that case 0.5 mm. So least count can be written as what? X divided by n. Okay, in our case it was 1 mm. It can be different. So you got this formula. Now after that, how do we take the reading? So to take the reading, we'll keep an object whose length we want to measure over here. Okay, so our scale will get shifted, right? So then the zero of the vernier scale, the zero of the vernier scale. Can you see this clearly?
Yes, sir.
Okay, so zero of the vernier scale will be somewhere on the main scale. It will align with something on main scale. So now you will measure distance up to this. Okay, distance up to this point. So how much is that? So this is, let's say, 1, this is 2, so this must be 1.9, right? So this is equal to what? This length. Okay, since this is 2, this is 1.9 in centimeters. Okay, after that, what do we do is we see which of the, sorry, which of the line on this vernier scale matches with the main scale. See, this is very close to 2. Okay, it is little bit lesser, but it's very close to 2. 8th or 9th line of vernier scale will match with one of the lines on main scale, because this is very close to 2. So it would be 1.98 or 1.99 or something. Okay, so that means either the 8th line or 9th line will match. If it was over here, then 5th line would match. Okay, so you got this? Yes, no?
Yes, sir.
Yes, sir.
So let's say 8th or 9th line matches. Let's say 8th line of the vernier scale matches with one of the line. Okay, on main scale, it gets aligned. So what would be your reading? It will be 1.98. And how to calculate it? So how to calculate it is you take the reading on main scale. Okay, so your main scale reading, line of vernier scale which matches, which gets aligned with main scale. Okay, so this is known as vernier scale reading. Okay, what is vernier scale reading? Line on the vernier scale which matches with the main scale, which gets aligned with one of the lines of main scale. So this multiplied by your least count, multiplied by your least count. Okay, so we found the least count for this scale. Okay, so this picture, this is some arbitrary picture, and this is not the least count for this scale, this is different. So if we use this, how much is the least count? 0.1 mm. Okay, so how much is this reading? This is 1.9 of centimeters in centimeters, plus this is 8 multiplied by the least count is 0.1 mm. And now if you want to write it in centimeters, what will you do? Mm to centimeters?
Multi multiply by 10 raised to power minus 1.
Multiply by 10 raised to minus 1. Okay, or multiply by 0.1. So if you multiply by 0.1, what do you get? 0.1 multiplied by 0.1, that is 0.01. So 0.01 multiplied by 8 is what? It is 0.08. Okay, so this is 0.08. So 1.9 plus 0.08. See, this is 1.98 in centimeters. Okay, so that's what we have written over here. Okay, so is it clear how to take the reading
Yes, sir.
to everybody?
Yes, sir.
Okay, have you
Yes.
seen the vernier scale? Okay, so there can be some error in the vernier scale. Okay, so let's say when the jaws of the vernier scale they are closed, then what should happen? Zero of the vernier scale, this is your vernier scale, this is the main scale, so zero of the vernier scale should match with zero of the main scale. Okay, so that's what we are seeing over here. Jaws are intact. Okay, they are not separated, you are not measuring anything, so your device is closed. So zero of your main scale and zero of the vernier scale, they should match. Got it? Okay, because your reading is zero, so nothing should show on the main scale, nothing should show on the vernier scale, right?
Yes, sir.
Yes or no? So if it is like that, then there is no error. Okay, then there is no error, no zero error, your device is good. But now what can happen? Let's say you are measuring zero, so jaws are closed, so your vernier scale, zero of the vernier scale is either before the zero line or it falls after the zero line of main scale, then there would be some error. Okay, so if zero of the vernier scale it falls after, okay, it falls after the zero of your main scale, okay, this is positive error. And this is because your vernier scale is measuring something, because you are taking measurement on your main scale and your vernier scale is showing this result. Okay, so this would be positive, and if it shows like this, so this would be negative error. Okay,
But sir, when it comes to left, we take positive error.
now when it comes
I
to,
think so. I don't.
see, what I'm saying is, okay, so this is your zero, this is zero of your main scale, and your vernier scale, it's showing some result. Okay, it is not matching with the zero, so it is measuring something extra.
Yes, sir.
Okay, and in this case, if it falls before, if it falls before the zero, then it's showing some lesser sorry, it is showing lesser value.
Yes, sir.
Okay, so this would be positive, this would be positive, and this would be negative.
Yes, sir.
Okay, so we have to memorize this. These are not physics concept, these are measurement. We have to memorize these things. If it falls afterwards, this is positive. Okay, and why so? Your vernier is showing some extra reading. Okay, and in this case, your vernier scale is showing lesser reading, so this is negative. All right.
Yes, sir.
Yes, no, there is confusion still. Yes or no, Sanjay?
Yes, sir.
Yes, sir.
Florence?
Oh,
Yes, sir.
Okay, so yeah, this one is positive and the other one is, this one is negative. All right, so this is how we'll measure the errors. Okay, zero error. This type of error, when the jaws of vernier scale are intact, this is known as zero error. Okay, and now how will you find it? So again, here none of the lines are matching, so this is not the good picture to show. But see, I can say the fourth one is very close. So if you can see this, fourth one is very close. So how much would be the error in this? It will be reading on the vernier scale, which is fourth line, multiplied by what? The least count of the vernier caliper. Okay, so the error in this will be 4 multiplied by 0.1 mm. Okay, and this is positive, so it is 4 multiplied by 0.1, that means it is 0.04 mm. Okay, and if it is positive, then what should we do? We should add it or subtract it?
subtract.
We should subtract. Okay, because it's showing extra. Okay, it is showing extra reading, so we have to subtract it, right?
Yes, sir.
Yes, sir.
Okay, and in this case, you can see it is exactly at halfway. So fifth line of vernier matches with fourth line of main scale. Okay, so here the reading on your vernier scale, it is how much? It's it's 5. Okay, not this pen. It is 5. So 5 multiplied by 0.1 mm, it is equal to what? 0.5 mm. But this is negative. So if there is a case like this, then what should we do? We should add this much. Okay, so let's say you are measuring any length, it's 1.98, it's showing 1.98, so you should add 0.5 mm into that. Okay, for this case you should subtract 0.4 mm from that. Okay, is it clear?
Yes,
Yes, sir.
sir.
Yes, sir.
Okay, good. So this is the theory of vernier caliper. It's very short. Now let's see some problems. Okay, so this is from NEET 2020, I guess. The main scale of vernier caliper has n divisions per centimeter. Okay, so how much is the least count of main scale?
N minus 1.
No, least count of main scale. I'm asking, not about the vernier scale. If it has, see, this 1 centimeter distance. Okay, 1 centimeter distance, it is divided into 10 parts.
0.1 millimeter.
Yeah, no, this will be, see, the scale that we use in this one, 1 centimeter is divided into what? 10 parts. So the minimum reading that can be taken with main scale, it is how much? it is 1 by 10 of a centimeter. Okay, this is 1 by 10th of a centimeter. Okay, or 1 centimeter divided by 10, which we call 1 mm. Now, instead of 10, if it is divided into n parts, how much is the minimum reading that can be taken by main scale? See, here, this 1 centimeter distance, it is divided into how many parts?
10 parts.
10 parts. Okay.
10.
So each part is equal to what? 1/10 of this much length, right? If you take 10, if you take 10 such lengths, okay, you get this much length. So how much is this one division? It is 1/10 of this much length. Yes, no?
Yes, sir.
Yes, sir.
Okay, this is 1/10. So now instead of 10, let's say I divided it 5 parts. So what will be the least count then? What will be the reading, minimum reading that I can take? It will be 1 by 5.
Yes, sir.
Yes, sir.
Okay, so now this is divided in n parts, let's say. So it will be
1 by n.
1 by
1
n,
by
1
n.
by.
right? It will be 1 by n. So you got your main scale division. It is equal to what? 1 by n. Okay, after that, see, so n divisions of 1 year scale coincide with n minus 1 divisions of main scale. Okay, n divisions of 1 year scale match with n minus 1 division of main scale. The least count of 1 year caliper is. So it's given that n division of 1 year scale, we have seen this, but I am teaching once again. It matches with what? N minus 1 division of main scale. Okay, so how much would be 1 division on 1 year scale? Take this n on the other side. So you get it is equal to 1 division of 1 year scale is equal to n minus 1 divided by n division of main scale. For least count, it's not 1 division of 1 year scale. We have to use our formula. It is 1 main scale division minus 1 year scale division. Okay. So how much would be that? 1 minus n minus 1 upon n of your division of main scale. Okay. And that comes out to be what? 1 upon n. Okay. So we have to memorize that. We have to memorize that formula. I am deriving it once again. Okay. So this comes out to be what? 1 upon n. Okay, we have seen that. So this 1 can be written as n upon n. So it is n upon n minus n minus 1 upon n. Okay, so this is equal to what? 1 upon n. So clear till this point?
Yes, sir.
Yes, sir.
But we have to memorize this actually. So this is equal to 1 upon n. We have actually we have derivation for that, and I am re-deriving it. Okay, so it is 1 upon n multiplied by main scale division. Clear? So what is your answer then?
Option B.
Okay, but how much is main scale division? It's not 1 centimeter. It is 1 upon n. Okay. So this one main scale division is 1 upon n, right?
Yes, sir.
So it is 1 upon n multiplied by 1 upon n. It is 1 upon n square. This is the answer.
Yes, sir.
Shall I explain it once again? Is there a confusion?
Yes, sir.
Okay. So see, first of all, what I am doing is, see, the main scale of vernier caliper has n divisions per centimeter. Okay, the main scale of vernier caliper has n divisions on the main scale. Okay, n divisions per centimeter. So let's say this is our scale. This is our scale. Okay, so our regular scale has 10 divisions per centimeter. Okay, so how much is one main scale division? So first we are finding out MSD, which is main scale division. How much is one main scale division? It is 1/10 of this, right? It is 1/10 of 1 centimeter, which is equal to what? 1 mm. So now instead of 10, if it had 5 markings over here, okay, then it would be what? 1/5.
Yes, sir.
Okay, it will be 1/5 of centimeter. Instead of 5, let's say we have 20 markings. Okay, we don't have 10 markings. We are not dividing it in 10 parts. We are dividing it in 20 parts. Then each part is equal to what? 1 divided by 20.
Yes, sir.
Okay.
Yes, sir.
So in question, they are saying it's divided in n divisions. Okay, how many divisions? N divisions. So what do we get? So one division will be equal to what? So instead of 10, we are dividing in n parts. So it is 1 upon n,
Yes, sir.
right?
Yes, sir.
So each division on main scale is equal to 1 upon n of a centimeter. Okay, because 1 centimeter is divided in n parts. So each division is equal to what? 1 upon n. Okay. And then now, what is the least count of vernier caliper? So actually you should remember this formula directly. It is 1 upon n of the main scale division. Okay, it is 1 divided by the number of parts in which the vernier scale is divided. Okay, number of markings on vernier scale. Okay, so it is 1 upon n of main scale division. Okay, so it is 1 upon n multiplied by 1 upon n. So that is 1 by n square. All right.
Yes. Yes, sir.
Yes.
Next question is, in a slide caliper, m plus 1 number of vernier divisions is equal to m number of smallest main scale divisions. Okay. If d unit is magnitude of smallest main scale division, then the magnitude of vernier constant is. Okay. Now the question says m plus 1 number of vernier divisions equal to m number of, forget about the smallest, m number of main scale divisions. Okay, so what can I write? I can write m plus 1 division of the vernier scale is equal to m division of main scale. This we can write. Okay,
Yes, sir.
all right. Then if d unit is the magnitude of smallest main scale division, okay, so smallest main scale division is d unit, then the magnitude of vernier constant is. So what is vernier constant? Vernier constant is your vernier scale division. Okay, what is vernier constant? Vernier constant means vernier scale division. Okay, what's that? I'm sorry, it is this much distance. What is vernier constant? It is vernier scale division, not the least count. Okay, this much length is known as vernier constant.
Okay, sir.
Okay, so now you want to find I'm sorry, you want to find out the magnitude of vernier constant. Okay, so that is, you want to find out what? The one division of vernier scale. So take that m plus 1 on the other side. So it is 1 division of the vernier scale is equal to m divided by m plus 1 division of main scale. All right? Yes, no?
Yes,
No,
sir.
sir.
Okay. And D is the unit of magnitude of smallest main scale division. So main scale, on main scale division, how much is the one division? They're saying it is D. It's equal to D. So substitute this main in place of main scale, substitute D. Okay. So what do you get? You get m divided by m plus 1 multiplied by D. Right? This is your one
Yes, sir.
division of Vernier scale, and that is known as Vernier constant. All right. Let's see this one. The length of strip measured with a meter rod is 10 centimeter. Okay, there is a strip whose length is equal to 10 centimeter. Its width measured with vernier calipers is 1.00 centimeters. The least count of a meter rod is 0.1 centimeter, and that of vernier calipers is 0.01 centimeters. What will be error in this? Error in its area. So we want to find out error in the area. The least counts are given. Okay. So least count of meter rod is given. Least count of vernier caliper is also given. So what should we do? How to find error in the area? We have got this strip. Okay. So this is its length. This is the width. What will be area of the strip?
Length into width.
Length into width. Okay, area is length multiplied by width. What is the error? So we have studied that when we studied errors. So error in the area delta A upon A is equal to delta L upon L plus
Plus
delta
delta
W
W
by W. Okay. So if we have multiplication of two quantities, then the relative error in the resultant is equal to sum of the relative errors in those two quantities if we have multiplication or division. Okay, so relative error in the area is equal to relative error in the length plus relative error in the width. Got this?
Yes, sir.
Yes, sir.
And we want percentage error, so it will be just relative error multiplied by 100 everywhere. Yes.
Yes, sir.
So
So this is actually they have written there is a vernier caliper, there is a meter rod, but this is not a question based upon vernier caliper or meter rod. Okay, this is a simple question. This is error question. Okay, so see how much is the length. Length is equal to length is 10 centimeters. So L is 10 centimeters. This is 10 centimeters. Okay, it's 10.0 centimeters, and width is 1.0. This is 1.0 centimeters, and they're saying least count of the meter rod is 0.1 centimeter. So how much is the minimum value that can be measured in by the meter rod? It is 0.1 centimeter. So what is the value of error bit in the meter rod? It is equal to the least count. Okay, we studied about the significant figure last time. So if we talk about the length, this length, then every reading has some significant digits. What are they? So they are the digits which you are sure about and the first digit that you are not sure about. So first digit that you are not sure about is this one. Okay, here it can be 1 also, it can be 0, or it can be 9.9. Okay, it can be plus or minus 1 in this digit. Okay, so this is known as error digit. Okay, this is known as what? The error digit. So I think this statement actually is extra. Even if they had not given this, we could figure it out. How? So if I have this measurement, then I am certain about these two, but I am not so sure about the last digit. Okay, so what could be the error in this measurement? The error could be plus or minus 1 over here. Okay, so what could be the error? So delta L is equal to what? Plus or minus 0.1. Okay, this is known as the error digit. Got this?
Yes,
Yes.
sir.
Yes, sir.
Okay, actually they are explaining the question, so this part is not needed. Okay, and for 1 year caliper, see, they have given the precision, so it's 1.00. The precision is what? 2 digits after the decimal point. So what is the error bit in here? It is this digit,
0.01.
0.01. Okay, so there was no need to give this statement. Okay, we could just figure it out, right? So then there was something in the question. If this statement was not given, now there is nothing. They have given the error. Okay, so error in this one is delta W, which is 0.01 centimeter. Okay, so you have delta W, you have delta L, W and L. You have got everything. So it's equal to what? Delta L is 0.1, L is 10, 10.0. Now you are just dividing, multiplied by 100 plus delta W is how much? It is 0.01. Okay, so it is 0.01 divided by, it's 1.0 multiplied by 100. Okay, so if you multiply by 100 over here, you will get 1.0, and if you multiply by 100 here, okay, with this number you will get 10.0, right? 0.1. If you multiply by 10, it will be 1. If you multiply by 10 once again, you will get 10. So this is 10, sorry, this is 1 and this is also 1. So 1 plus 1. Okay, so 2% is your answer. So next question is, a student measuring the diameter of pencil of circular cross section with the help of 1 year scale records the following 4 readings. So this reading 5.50, then 5.55, then 5.45 and 5.65 mm. The average of, okay, average is also given. The average of these 4 readings is this much, 5.537 mm. And the standard deviation of the data is 0.07395 mm. Okay, this is the standard deviation. So standard deviation means the error. Okay, the average diameter of the pencil should therefore be recorded as. Who can tell me the answer?
Option D.
Option D.
D.
Yeah, option D is correct. Okay, all right. Others have question in this one? Okay, see, now you are doing some measurements. Okay, this is your first reading, this is second, third and fourth. So from the readings it is clear how much is the precision of your device. It is 0.01, right? We discussed it right now.
Yes, sir.
Okay, how
Yes,
much is
sir.
precision of your device? It is 0.01. It can give minimum reading up to that only. Okay, so this is your error bit, or you can say it is the precision bit also. Okay, so 0.01 is the minimum reading that you can take. Okay, so now you can take some numbers, you can add them and divide by a number of readings. Okay, so you will get some average. So you got this average, but does this mean that your device got this much precise?
No, sir.
No, you took readings with this device, which can give readings up to what? Second digit after the decimal point. It cannot go beyond that. It cannot give reading up to the third digit, fourth digit, right? So your device is not that much precise. Okay, so therefore the precision of this average, it should be corrected. Okay, so that's what we say, they are the significant digits. Okay, the significant numbers. Okay, so precision of this reading, it has to be corrected to what? Precision of the measuring device, which is what? 0.01. Okay, so second digit after the decimal point. So now this reading is 5.5375. Okay, and we want to round it up to this point. So what do we do? So here we have got 5. Okay, so if we round it up, this will become 8. Okay, so 538, 5.538. Then this 8, again we have to round it off. So it is greater than 5, therefore we'll increase this digit by 1. Okay, so it is 5.54. So this is your answer. All right, and since this is your reading, okay, this is the average reading, the error, it must be correct up to that decimal point only, up to that significant digit only.
Yes, sir.
Okay, so it
Yes,
will
sir.
be plus or minus how much? 0.07. So this one also we have to round it off. So it is 0.07395. Okay, so if we round it off, we have to just look at this number. It is less than 5, so we can forget about this. So it is 0.07. Okay, so your answer will be what? 5.54 plus or minus 0.07. Okay, let's proceed. So next question, diameter of a steel ball measured using vernier calipers, which has divisions of 0.1 centimeter on the main scale and 10 division on vernier scale. So first of all, what should you do? You have got the main scale division, okay, and 10 divisions on vernier scale. Okay, so what is the MSD?
0.1 centimeter.
It is 0.1 centimeter, right? Main scale division, it's given, okay, which has divisions of 0.1 centimeter on the main scale. It is 0.1 centimeters. Okay, and 10 divisions on vernier scale. So it has got 10 divisions on vernier scale, which match with 9 divisions on the main scale. Okay, they match with 9 divisions on the main scale. So now how to find the least count? Tell me.
MSD minus VSD.
Yeah, that will do when, okay, so I told you to memorize the formula. That will be derivation, right?
Least count is equal to 1 by n MSD.
1 by n of MSD. Okay, so least count is equal to 1 by n of MSD. That is equal to what? Least count is 1 upon n multiplied by MSD. Okay, so how much is that? 0.1 divided by n is equal to what? 10. Okay, n matches with n minus 1. So n is 10, right? So it is 0.1 divided by 10. So it is 0.01, 0.01 centimeters, right? You got the least count. After that, 3 such measurements of the ball are given as, so this is the table, 3 measurements are given over here. Okay, so what are we measuring? We are measuring diameter of a steel ball. All right, so these are 3 readings. So let's say this is diameter 1, diameter 2, diameter 3. Okay, if the zero error is, okay, question is there after that also, zero error is minus 0.03 centimeter, then the mean corrected diameter is, okay, so what do we have to do? We have to add this or subtract this?
Add.
Add this.
Okay, because this is negative 0 error. So we have to add 0.03 centimeters. Okay, in all readings. So let's say diameter 1. Okay, let's call this diameter 1. How much would be that? Main scale, it is given in centimeter. Okay, so 0.5 centimeters plus vernier scale division is 8 multiplied by the least count. How much is the least count? Least count is 1 upon
0.1 mil.
Yeah, it is 0.01. Okay, so this is the reading, but we have to add something.
0.03.
Yeah, we have to add the
Zero
zero
error.
error. So plus 0.03. This is the zero error. Okay, so let's calculate it. Let's calculate it here. It will be 0.5. Okay, so 8 multiplied by 0.01 is 0.08. So 0.08 plus 0.03. How much would be that? 0.08 plus 0.03 would be 0.11, right?
Yes, sir. 0.61 total.
0.61. This is equal to 0.61 centimeters. T2 0.5 plus 4 multiplied by 0.01 plus 0.03. So this is 0.04 plus 0.03, 0.07, right? 0.07 plus 0.5, 0.57.
0.57.
And D3 is 0.5 plus how much? 6 multiplied by 0.01 plus 0.03. So it is 0.06 plus 0.03, which is 0.09. So 0.09,
0.59.
okay, 0.59. Okay, and what would be average of this? So average of this would be 0.59, right?